Okay, welcome back. We're on section 2.2 now. For some reason 2.1 doesn't exist. And what we gotta figure out in section 2.2 is what is a derivative. And the derivative is rate of change at a specific point. And you might be asking, what does that mean exactly? Well, let's look at a simple function on Desmos, 2x plus 1, graphed out here, right? Now the rate of change is 2, because you can tell from the equation, for every one x value, the graph moves up by 2 y values. So the rate of change is 2. But for a function like x squared, there is no one constant rate of change, because from 0 to 1, the y value increases by 1. But from 1 to 2, the y value increases by 3, from 1 to 4. Yeah. And from 2 to 3, the y value changes by 5, from the y value 4 to 9. So obviously the rate of change is increasing. But what the derivative tells us is what's the rate of change at a specific point. Like, what's the rate of change at the point x equals 2? Because it's going to be different than the rate of change at the point x equals 1. So let's try to figure it out how to do it. And what we're going to need first is the formula to figure out the rate of change, which is y2 minus y1 all over x2 minus x1. That's the formula for the rate of change. Now let's try to figure out the rate of change at the point x equals 1 for the function x squared. Let's give an example. Let's try to find the average rate of change from the point x equals 1 to x equals 3 for this function. So y2 would be 9, because 3 squared is 9, and then y1 would be 1, and x2 would be 3, and x1 would be 1. So the rate of change between the points 1 and 3 would be 8/3 on average. Now let's try it again with the point 2, 1 and 2. So y2 would be 4, y1 would be 1, and then x2 would be 2, and then x1 would be 1, and then you get 3/2. The average rate of change between the 1 and 2 is 3/2. I mean, sorry, just 3. I did the math wrong, just 3. So, as you can see, the rate of change for this, the average rate of change increases as you go. But the question is, how do we get the rate of change at this point, x equals 1? Well, this is where we can use limits. So we clearly need this distance x as our first point. But we also need another point, but it has to be as close to x as possible if we want the rate of change just there. So this distance, whatever it is, we will call h. But we need h to be as close to possible as x to get the instantaneous rate of change. So h has to approach 0, because that is the closest it's going to get to just being x. So we do the limit as h approaches 0, and then the y value is going to be f of x plus h for y2 minus f of x for y1, and then the x2 will be x plus h, then x1 will be just x, so minus x, and these x's cancel each other out. So we get the formula for a derivative is the limit as h, that's really bad, as h approaches 0 of f of x plus h minus f of x all over h. And this is because h is going to be approaching 0 to get to a point as close as possible to x, to get the rate of change at a specific point. And then we can try a few examples with this. Okay, I forgot to add this, but there's a notation for a derivative. So if you took a derivative of a function, you can either write it as f prime of x equals this, which pretty much means the derivative of the function of x, or you can write dy over dx if it's given in the y equals form and just do this. You just gotta know that. Okay, now it's time for the example problem. We're going to try to find the derivative of the function 2x squared minus 7x plus 1 using the formula. So let's just do that real quick. Do 2 times x plus h squared minus 7 times x plus h plus 1. And you can see since it's f of x plus h, I replaced all the x's with x plus h's. And then you just do minus the original function, which is 2x squared, in parentheses, minus 7x plus 1 all over h. And we just gotta multiply everything and then cancel. So we got 2x squared plus 4xh plus 2h squared minus 7x minus 7h plus 1 minus 2x squared plus 7x minus 1. I just gotta cancel. The 1's cancel, the 7x's cancel, and the 2x squareds cancel, and we're left with 4xh plus 2h squared minus 7h all over h. And since they all have an h in them, we can cancel it out. So this h will cancel with one of these each. Now we have 4x plus 2h minus 7, but it's still, the function is, to find a derivative, you take the limit as h approaches 0. Now we can substitute 0 for the h, and it's just going to be 4x minus 7 is the derivative of the function, which is 4x minus 7. And that's how you do a derivative like that. Okay, we also have to talk about what a tangent line is. So, let's say we find that this is x squared, by the way, x squared. Let's say we find the derivative of this at the point 1. And the rate of change at this point, well, we can do it real quick, but the answer is, the rate of change is going to be 1. M equals 1. The derivative at the point 1 is 1. But this means that the exact rate of change at the point 1 for the x squared is 1. But to find the tangent line, well, a tangent line is just barely touching at the point 1. So it's going to go across, it's not straight at all, but it's just going to go across like this in either direction straight. And some problems ask for that. And the formula to find it is y minus y1 equals m being the rate of change, or the derivative, m times x minus x1. There's a few example problems using this, and it's probably better to understand that way. But it's asking pretty much, once you find the slope for the, most of you are probably used to seeing y equals mx plus b. It's pretty much just figuring out this at the point of the derivative that you're finding. So let's look at an example problem real quick. Okay, this is a practice problem. It's pretty normal. If we know f of 5 equals negative 2, and the derivative of f is given by f prime of x equals x cubed minus 2 all over x, write an equation for the line tangent to the graph at x equals 5. So we're going to be since it's a tangent line, we're going to be working with the formula y minus y1 equals m over x minus x1. So we know f of 5 is negative 2. So we have our y1 and x1. y1 equals negative 2, should be y, and x1 equals 5. Now we just have to figure out the m. And they give us the formula to figure out m right here, the f prime of x formula. So we do 5 cubed, because we plug in 5 for x, and it's asking at the point x equals 5. 5 cubed minus 2 all over 5. 5 cubed is 125, because, minus 2 all over 5. 5. That's an awful 5. 5, and you get 123 over 5. Then you just gotta write it out, and the tangent line is y minus -2, which would become plus 2, equals awful equal sign, equals 123 over 5 times x minus 5. And that's the tangent line. And that's just how you do it. You figure out the slope and the two values, the x value and the y value. That's a normal practice problem to figure out the tangent line. I think that's kind of it for 2.2.